Hi everyone, I'm Gil. Welcome to this month's webinar. I've done a couple of webinars already about working with AI and testing AI. This is like not a combination of them, but another look of how quality is perceived, measured, and we're going to dissect what we're doing across the SDLC. The reason I'm doing this is that as I'm working with people who use AI, as I'm using AI myself, I started thinking about not just like generating code, we'll talk about that, or features or applications or full applications or not so working applications or tests, but also what AI does. And as I was thinking about it, I got to a point where I thought about, well, AI amplifies, and it amplifies our productivity, of course, but it also amplifies other kinds of problems. And we want AI to be the speed engine. And if you looked at the other webinars I did about testing AI features, for example, you might have thought, well, that kind of slows the train down. And we don't want that. We want like to keep the train going. But in order to do that, we need to identify problems wherever they may be. And if we keep doing the things that we did until today, or until the days before AI, I think we'll be missing stuff, and we're going to bump into these things because they're pretty large, and we don't see them because we're writing too fast. So this session is about these things. I'm going to talk about different things across the development process, and what we're used to doing, and how we're used to thinking, and what we might get eaten by. So we'll talk about these monsters in a second. Until we get to these monsters, it's me. I'm Gil. I'm a trainer and a consultant, and I help testers, developers, everyone already who wants to develop good software to be better, be more productive, especially in these days where things are running in the speed of 10x or whatever. And this session and the rest of my other webinars and the videos and blogs talk about that. So if you're interested in some kind of help in implementation of practices, legacy practices, like who needs unit testing anymore? Like everybody is, or API tests or something like that, give me a ring. I can help you. So I've identified 9 monsters, probably a lot more, but these are the things that I think we should be looking at and look at them differently than we used to. All of the things that we're going to talk about, different aspects of the development today. The first one is going to be from requirement. We're going to be about design and architecture and testing, and even DevOps, things that affect our development. And if you look at it, you'll see that if we don't apply something to it, manage it, identify it, or at least try to identify it first, it's going to put the brakes for us because we're going to bump into that. The first one, I think, yeah, is the intent gap. So what is intent? So like I said, I'm going to start with the requirements. Usually when we talk about requirements, kind of thinking like stories and epics in Jira, or like very too heavy to lift documents, or too heavy to lift, too heavy to read digital documents. And that is true. But there's a reason we do this. And the reason is that our requirements, basically, they are our communication tool. We say we want to get there, and we kind of derive everything from it, including questions. Even if we don't know everything, there's some kind of anchor we can go to and say, well, this is how it should work. This is maybe why it should work. Didn't see that for a while, but let's say it does. This is how it should work, and this is how we will know how it will work. Maybe even sometimes, maybe this is how we will know how it will not work, or it's not working. So this probably is an acceptance criteria that we may or may not specify. And for that, everything kind of drills down like in old good old waterfall, where we have design, which is supposed to answer the questions, how we're going to build that, and the code, which is building that, the testing, well, how do we make sure that what we build actually works? So requirements are, in any form, very important. However, in the age of AI, what works and what isn't kind of get very gray. So I'll give you an example. I blog a lot, and I showed a couple of videos about my API analysis agent, which is kind of a smart, dumb tool that gets an API and spits out a test plan. And one of the requirements I gave it was like, give me 5 valid cases and 5 edge cases. Okay, and then the language can be debatable. And ran it a couple of times, and sometimes I got what I wanted, 5 valid cases and 5 invalid cases. In some cases, it didn't get exactly what I wanted, which is not exactly the right number. So if you look at it like it got like 5 valid cases, 5 edge cases or invalid cases, sorry, 4, that meant that an automated test that will look at the number of tests or acceptance criteria will tell you this doesn't work. However, looking at the quality of these so-called invalid cases, you can see that they are very good. And sometimes they are either more good at finding bugs or something like that, compared to the other valid cases, which are probably generic and stuff like that. So technically, this is like a failure because I specified 5 and 5, and this will fail. Is that really a failure? It could be better if it would be like 5 cases, 5 good cases. But if I compare 4 good cases to 4 not so good, 5 not so good cases, things gets murky. Now, why is that important? It's important because it's hard to define that, especially upfront, because you're going to run against a model, you don't know what it's going to do. And usually what happens, we kind of say, this looks okay. We should probably do something about it. And what we usually do is say, this is good enough. Try to remember that 4 good enough results are also good. And we may change our tests and stuff like that, but we don't go back to the requirements. And what we used to do, and I know it sounds very waterfallish, not agile and stuff like that, is that we probably either remember or maybe go back once a month, a year, a decade to the requirements and update them. But today we need to do that a lot more because we learn a lot more and a lot faster. So the feedback loop is a lot shorter because we can generate the implementation very quickly and we can see the results very quickly. And then we learn that, this is also good, or this should not happen at all. So our acceptance criteria, our requirements, our tool of communication needs to be updated a lot more. Now, how do we know that we are doing that? So, like I said, this is a shift in how we should do stuff. And I'm going to give you options today. I'm not going to give you this is how you do this because we're still in learning mode, everyone. But it is something that we should think about how we do that. And in order to tell you, hey, we're improving on that front, yes, we need to actually track how much we're changing our acceptance criteria, our requirements. If we do that, we know that, hey, we're working at the speed where we're learning stuff and we're documenting stuff, and the rest of the teams will know what we're learning. So obviously you can actually spread this information in different ways, kind of tied to requirements and acceptance criteria, because basically we learn it at the testing point to say, this is what good looks like. This is what bad looks like. We need to communicate that as well. And sometimes it will be like, it's okay, we can live with that. And we can live with that is also worth documenting sometimes. So I'm not saying going to live inside a Confluence or something like that, because I probably think this is going to be a nightmare. But one of the things that we should be looking at is more updates. Because if I was looking just myself and I was working alone, that's okay. Even working for my memory is not that good. But if we're working on a project with a lot of teams working on it, the impact of what we can have in terms of understanding how the system actually works is a lot bigger, because if we don't propagate this knowledge, other people will create things differently, think differently, assume differently about the system, which is probably a good point not to start doing stuff. Which brings me back to monster number 2. Monster number 2 is about side effects, butterfly effects. Our system used to be complex, and complexity means that you tweak something here, something happens here. And we kind of got used to that. We kind of got used to living with that to an extent. But we're kind of, like I said, AI amplifies everything. With AI, things going to be amplified, including these side effects. So you say to your API analysis engine, as I did, you're costing me too much. I'll kind of create a concise prompt when you're actually sending it to the model. And it didn't actually, well, it actually did that, but it cut down some requests to edge cases. So I started not getting what I really wanted, was like a full test plan, more like a generic test plan, something like that. In terms of quality, I didn't get what I wanted. So this is like a weird side effect, yeah? It's like, I want to save money on tokens. I get it. It has an effect on quality. Now, this is like, I wouldn't say it's weird. It could be expected, obviously, but we're not used to thinking about like that. We used to think about linearity. You change something here, something happens here because we not understand the connection, we understand how the system is built. This is like kind of weird. Things if I asked for fewer cases and I got fewer cases, I can see the connection. But sometimes we don't even see the root cause of what we're doing because it appears somewhere. And of course, we know about systems that run AI. You have indeterminate results, you have irreproducible results, and it becomes a lot and a lot harder to do and connect the dots, which is a problem because we're building something that we don't understand. We don't kind of, like I said, pull a lever here, and everything else explodes. We need to continue doing that because, like before, if we stop pulling levers, we kind of stagnate. Can't do that. And everything that we do on things like that, where did this happen? When did this happen? Why did this happen? We don't know. We need to stop and think. We don't like to stop. That's a problem. So in order to continue doing that, we need to, I'm going to say again the dirty word, document a bit more. We don't know what we'll see, but we probably will see a lot more weird stuff. And today it's like you think about flaky tests or something like that. Kind of rely on our memory that, I've seen that last week. That looks similar to what. Here's a lot of things going to happen that are not similar to each other, maybe very quickly. And out of all this noise, we'll have to collect all these points together and put the puzzle back together again. So it's going to be hard working just from memory. So we need to write down a lot more, and maybe we'll start to see the pattern there. Of course, we can use AI to do this for us if it can, because like I said, AI is a speed engine. It's also a speed engine for us for debugging stuff. But we need information in order to at least analyze it. So we need to identify side effects. We need to close the feedback loop. Once we understand the root cause of what caused this, and this probably will happen because more and more cases like this will happen, we can start connecting the dots. And when we do, we need to put guardrails or automation tests, make sure that these, not only the symptoms, but also the root causes will not happen again. And they are fixed and they will not return. So again, quicker feedback loop, and how we understand development, we need to feed it back, feed more information or record more information, feed it back into the system in order for us to continue moving forward. Okay, next one is architecture blindness. And if you've read, seen things about me before, I always talk about the stability and knowing what you're testing, but this has become a lot more important. So what is blindness that I'm talking about? Let's assume that you're saying, I'm going to look at this system as a black box. If it's a black box, I don't know what's happening inside. And remember those weird side effects? I won't even know where they're coming from. Now, part of our job, regardless of what our role is like we want to deliver. Therefore, we need to debug stuff because things will break. We need to analyze stuff. We need to fix stuff. And it starts with knowing more about the system. And if we're not, or kind of either aware of how the system is working, and this is like not just talking about from a testing perspective, but also a development perspective, we're going to do a very bad job at it. So, for example, let's say my agent, has basically three components. It has a RAG, a retrieval data, has all kinds of things in it, and we have my code because it's brilliant and it has tests as well. And therefore, it's brilliant. That kind of gets the input and calls the RAG, and a RAG retrieves some kind of context that we're going to send to the model, and my code does something with it, and it sends to the prompt, sent with a prompt to the model, gets the response, does something in it, and returns it. So like an agent that does something, and something is wrong. Now, something is wrong. It's not completely wrong. It could be like, it's not doing what it's supposed to do weirdly. Where is the problem coming from? Now, if it's a black box, you'd say, the model's a problem. Everything is a model problem, but especially if I have tests for my code. But it could be a lot of things, like it could be the data in the RAG that I'm building the context on. It could be not updated, conflicting, anything. My code could be creating those side effects, like creating stuff, pulling stuff out of the context. Or it could be that the model itself, it's like, it could be, it's not, I don't say all never believe the model, but sometimes it is its problem. And maybe it's set incorrectly for us. Maybe we asked it to be more creative, like with the high temperature, to call temperature the settings that tell the model how to be more creative or stuff like that. Yeah, maybe it's set up to be a lot more or less, a little less creative than we want it to be. Without understanding these kind of, it's still information, how the system is built, what kind of data passes, what kind of data doesn't pass. Without these things, debugging becomes a lot harder. It becomes a lot slower. Okay, so what we need is really more information about the system, and I've been saying it for years for testers. Testers need to know how the system is built, like lose the black box dogma, but it's also true for other people because more people are going to work together very quickly, like in very quick cycles. Everybody needs to know a lot more about how the system works, where the weird parts are, where the deterministic parts are, what is covered with deterministic test, what is not, what is covered with indeterminate test, what is flakiness in the system. It's not just testers or developers. We need to know as a team a lot more about what's going on, because otherwise we'll slow down. Okay, so you've probably heard a few stories about security problems. It could be security, safety. It could be anything that introduces risk into the system. I gave you an example in one of the webinars about the Chevrolet chatbot. I sold it Chevy for $1, but it gets a lot more problematic. But this is like if we had tested it, yes, how would we know to test these kind of things? So it's not just prompt injection. Like a prompt injection, I talked about that in the past. Security as let's say a skill set in the team is usually something you don't see in organizations. Organizations usually either kind of offload this to somebody else, like somebody will come in, do some pen testing or something like that, and it's augmented today with AI testing and do test for prompt injection, stuff like that. But usually we don't develop these kind of skills in-house. It's one of these things that we thought, and we still think, about as too narrow, and until we need it, like having an expert about this in the organization becomes like too expensive. And what happens is sometimes it's boring, and therefore not a lot of people get into that. And that's a problem because like the risks are not going away. They are coming in. There was a nice blog from CyberArk about history poisoning. They had a case where they had APIs and the API descriptions in the database. And the descriptions contained fragments of a malicious prompt. So when you ask the prompt, give me all the API's description, kind of build the bomb together and created some malicious operation, or could do that. So this is like a whole new world of risks, and we used to think about these things as maybe my source code linter will find problems for it, or we'll wait 3 months and then somebody else will take care of that. But again, we're kind of developing in like very quick speeds. We can introduce something today that in 3 months will be a lot late to find out about it. So the problem is that, first of all, we need to understand a couple of things. We need to understand security, safety, whatever the rep is, we need to think of it as something that we need to do as well in terms of testing, or at least identify as risks and do something about them. And it can come from different directions. Like who would thought that a description field in the database could contain like a part of a bomb? Nobody would. So we need to understand where the threats come from. And that means we need to know more about these kind of risks. The risk map has become a lot bigger. Like I said, AI amplifies everything, that too. And we need to start thinking about these things. If we used to be easier not to, or let the tools take care of that, or maybe get somebody smarter, but they go in and scan things a lot more than they did in the old days 2 years ago. That's monster number 4. The next one is something that this one's kind of bothered me but I couldn't put my point on it until I actually thought about something's happening here that, especially when we're generating code, and Again, this is something that I saw with a client a few weeks back. A developer was working on his computer, generating stuff, and then he froze. And I asked him, "Well, why are you freezing?" Touched him first to see if it's really freezing. It wasn't. He was just like waiting for something, and he said it more than normal. And I said I ran out of tokens. We kind of laughed at it because like he actually forgot how to develop without Mr. Claude Code there. But like I said, AI amplifies things. We can generate a lot more code, and we don't review all the code. Everybody tells you that they can review code, all the code. Even the things that the reasoning that you see when you're generating stuff inside the IDE, Kent Beck said it best. He said that IDEs are not the tools that we need today. It's not editors anymore. We need better tools for reviewing. What we have is not good enough. Yes, we try to do the same things that we did before, like review commits and compare them, but this could be like a lot of things that our brains want to understand, like what is the difference between things, but they're not there, like our brains. The agents, they're there already. So that's step one. Step one is that, yeah, we don't review everything. We kind of press accept all, and things will happen. Maybe the testers will find out what is wrong with this code. But we'll talk about that in a few seconds. But let's go to step two. What happens 5 years from now? 5 years from now, we're going to have a lot more people, assuming the number of people in the organization stays the same, who don't know how the system works, because we're going to like do this like I wouldn't say exponentially, but we're going to generate more and more and more code, which we are going to review a lot less. And that's a problem. Remember what we're talking about, not just like monsters, things that will slow us down. You think it's going to happen in 5 years? We're going to start seeing that like in 6 months. And what's the problem? We don't know. Kind of equals to the blindness problem, only this time we caused it. So this is like a very big thing. Like if you think about technical debt, we used to say that technical debt, this is the thing that we would blame for delivering late. Think how much technical debt we're generating right now. That's a lot, all over the world, all kinds of applications. But apocalypse is really coming. So and that means like we need to change how we're again, like I said, still learning things that worked for me, and this is kind of feeling like I'm slowing myself down, but it's like TDD for me. Like you do small steps, you run faster, smaller commits. This is something that at the organization level, the R&D level, you can actually check, like don't allow big commits. In turn, maybe, hopefully, that means that apart from AI reviewing your code, which I'm guessing you do, and static code analysis, stuff like that, maybe other people will review more of that code. Like put a constraint and try to push people to do that. Again, the long term, and it's not that long, it's going to be a real disaster for organizations. They will not know what they're doing, and we kind of say, oh, AI will save me. AI can read the repos and see what's happening there, which is true up to a point. And like it probably will not fail on the main things, the valid cases, the happy paths, all the niceties. But remember, we're building something, most of us are building something complex. Now it becomes complexer. And really, all the intricacies and dependencies and stuff like that, how do we make sure this still works? And when it doesn't, how do we find the problem? That would be a major problem. If we don't manage the process, we understand this is a risk. We need to do things differently. We will probably bump into walls every 3 hours or something. Okay, next. So let's continue this line of how we're digging ourselves a very big hole. So we're generating a lot of code. Obviously, we need to review it. We talked about that. That's hard. We probably won't do it. We need to verify it. It's actually working. Can we do this? Well, when I tried this trick and I blogged about it, I kind of went to my API analysis engine and did some reverse engineering. I took an output plan and said that this is like a test plan that is usually going to be generated. And I asked Mr. AI, that it was Gemini, read that, identify all the parameters that can change. Like if I wanted to do like full mapping of automated tests for these things, I would need to consider all kinds of cases, right? So identify all the things that can change here. So I will be prepared to everything in it. I was not actually going to do that, but as an exercise, I wanted to see what I mean. It gave me a list this big. And this list was classes of things, right? These were not examples. And these classes of things also kind of broke down the classes. So for example, the things that they gave me and I wanted to dig in was the complexity of the API request body. So if the API request body comes in different shapes and sizes, this is going to be affecting, obviously, the test plan. Okay. So I said, give me ideas of like how is it different, and it broke it down for different classes, subclasses, like a simple body or a vague body, which like simple means that the names are okay. They're kind of readable. You can infer from them what their meaning is, name, email, stuff like that. Something vague, like input 1, input 2. It's not completely understood what is being passed here. And nested and hierarchies and stuff like that. And on top of that, like invalid stuff, combination of those, all kinds of things. So in the old world, 2 years ago, what happened is that we kind of lived in a sort of a fantasy land. When we said like, we know we're creating complex stuff. We can't test everything. Automation will help us. We know it won't cover everything, but it will give us a lot that we can trust, and the rest we can do manually or explore, do something like that. Talk about exploration in a second, but automation will save us. Now, this is true, but automation means that you need to generate code in a way that, well, first of all, write it yourself. Write it yourself. Yeah, we know we won't cover everything. Okay. If we can apply the same rules of what we did today, we'll cover a lot less. But let's generate stuff. I'll show you an example of something that I've seen a lot. It's very simple, and you've probably seen it yourself. Okay, so generate a test for an API. Okay, generate something like this. You've probably done this before to generate stuff. Like I've seen code test generated for 20 years now, and a lot of tests that are generated come directly from the code, and sometimes it's not exactly what you want. For example, here you want not just the status code, you want to make sure that this is a post API, it can create something, you want to get back things in there. Then if you want something better, then you'll need to specify that, like give me something a lot more strict and give me the check on the responses and also do a get to make sure that things are there. You'll need to work a lot harder to get what you actually want. Now, this is learnable. You can write skills in the agent file so that you can do that. But remember what we want. We want to cover this in things that will tell us, yeah, your system is okay. This will pass, but if it doesn't check everything that we want, we kind of live in a fantasy green world. We don't want that. So we get back to the other problems, right? We can generate a lot of tests. We still need to review them because otherwise, what have we done? And remember, these things can pass. And if they pass, we need to make sure they pass for the right reason and give us the confidence that our system is working the way we want it. So just generating tests is still not the answer. I don't have the right answer for that, except, again, go small and review what you're doing. Another thing, and web testing with AI was half of it was trying to generate a test that will pass the login page and get to the actual thing that I actually wanted, which was the product page, and it couldn't do that. Why couldn't it do it? Different reasons. One of them was even that this was like the browser stack demo, and when you open the drop down for the usernames that you need to connect, it actually hit the button, so it couldn't click the button. Now you say, okay, it will become smarter and so on, but I want to give it as an example because when I gave it in the webinar, it was like, I think 20 minutes explaining the steps that I took and why everything didn't work out. And in fact, I actually worked on this for less than a day on this example, on and off. So take that and multiply that with things that won't work. So you will probably say, I'll make an agent that will run this and create a test and run it, and it will fail and it will fix it. Yes, maybe it will work. Probably when it doesn't, you'll spend a lot of time on trying to understand, why is this test failing? I need to debug the system, which remember, I don't really know because time has passed and the AI did this for me. Kind of lengthen the part where it's hard to maintain the system. But it's not like you don't, like, I'm not saying don't use AI. Like the same feedback like I showed you before, can be used to, okay, maybe we need to go a bit differently. So instead of that, I'll use some BDD scripts to the AI will get something from a Jira ticket, and it will generate a BDD script for me, like I did. It will create a feature file, from text, like of a Jira ticket or something like that. And you see, not highlighted, but it does work. And it created step definitions for me as well, runnable. I still need to review. I still need to review the cases. And again, this is like a test. I still need to make sure that, yeah, it still works and does what it actually, check what I wanted to do. But I need to make these things happen. If permutation is a problem, well, exploration is a bigger problem, right? Because permutations is the things at least that we can think about what we know, and we need to cover that. Exploration is supposed to help us identify the things that we don't know. So the unknown unknowns, right? And what we used to do until today is kind of plan our plan for testing and said, okay, we automate this kind of stuff. And knowing that when we are automating this list, the rest of the time that we'll do is exploring. Okay, but we've got a lot more code going in there and a lot more model behavior going in there. If we still leave enough for exploring the same way that we did before, we won't get there because of the permutations. And the second thing is that what's left needs to explore a lot more than we did before. Like the infinite becomes a lot bigger. So just exploring, first of all, the way we did before is not going to cut it. In terms of like we want to release in a way that we are confident in, right? So we need to do things like risk-based sampling. Like we need to think a bit more about the areas that we want to explore and what kind of things we want to focus. And testability. I mean, we want to explore and make sure that we can tweak the system to do what we want, and we need to be able to see what it's doing a lot more. Exploration becomes a lot more managed for not a great word, because exploring is still exploring, but we still need to do some planning up front about how we're going to attack this, make sure that we can do this, see what's happening, and need to evaluate our risks better, what we want to explore, and it needs to be planned, like I said, in a way that's going to be effective. We won't cover everything. It's a lot more than we did before, and we couldn't do that either. But in order, like I said, we're exploring a new ground here. And in order to do that, we need to switch the way that we were thinking before that, and like just leaving time enough for exploration is not going to cut it. Now down to the final two. Okay, the first one was the token tax. And I talked about it like in the beginning, like a side effect, but this is a bit different. It used to be, and you know that test runs, automation test runs, were like for free. What does it mean? Yes, you needed a machine, or maybe requisite the cloud machine for that, and you needed a CI machine. You would run it, and if it failed, you would run it again. But everyone was like for free. There's no penalty in running it again. This is no longer true, because if you have AI steps in the meeting or AI features in there, it's going to cost you money, tokens or money. So much like security, in a way, it's another way of thinking about development and testing that we're not used to, and we need to get used to it, because currently that means that you have the budget. If you have a budget, that means that you can't run millions of tests. Maybe you can because you're very rich, but other than that, maybe you can't run everything all the time. You need to manage your test suites differently. You need to be aware that it costs you money, and you need to be aware of how much it costs you, and not wait for at the end of the month when you get the invoice, because maybe you ran out of luck or you're coming very close. We need to think about it differently. Maybe budgets, tokens per test run or per test, but we need to plan it differently. So what happens to the code when it runs out of tokens? Does it stop the whole program from running? No, the code does not. But if your code is, it depends on what you're doing. If your code calls a model and you run out of tokens, you will get an error and your test will start failing. If your code by itself doesn't do anything, but the CI does some kind of AI things, doing statistics or running as part of process, it will cost you. If you're running it like regular application before, it will not cost you. What you mean is that engineers would need to anticipate such an edge case and send alerts to the finance team. In a way, yes. We need to be aware of our budget. And we used to say things like that, well, that's a DevOps problem or somebody else in finance. It's more like a DevOps problem. But yes, it is becoming our problem. We need to be aware of when we stop. The problem is not that we run out of money. It could be, but the real problem is that we run out of feedback. If our tests don't give us answers, we don't know where we are. We're back to manual, like Stone Age. Final thing. Oh, but what if the code is using AI scripts and requests as part of the process? Same thing. If the code runs in production and calls AI, that's one thing. If part of the CI, if the parts of the CI run things, run agents that run scripts and use tokens, it will be part of that budget. If it's before I commit the code, I have a budget for that as well, but that's not, we don't consider that a problem, except for the developer who stared at the screen and didn't know what to do. Okay, last monster, because we need to finish. Drift. I talked about drift in terms of quality, like things changing over time because models are changing over time. I want you to leave you with a headache, though, because when we talked about that, we said, oh, okay, we'll do something about that. We will write other kinds of tests that look at the drift and identify the drift. And every time we do this, maybe feed that into an AI model that will check how our drift is doing. And we know before we hit the wall if something bad happens. Yeah, okay. But the problem is, apart from that, which is a big problem by itself, is not how we do that, but let's say you get to work each day, and each day you look at it, and everything we talked about is okay. You've kind of solved everything around it, like the permutation and stuff like that. And you see a report, and it's green. Everything's working. And everything was green yesterday, and everything will be green tomorrow. But these are not the same greens. It doesn't mean the same thing because things change under our basement. That's bigger problem. Because if we calling code that either changes because AI changes it, or because our code calls a model and the model changes behavior, and our tests are still green, let's say they are green, is it the same green? Because we tested everything, at least in automation, everything that we could think of. Can say, okay, this within this box, everything is okay. So yeah, we're still in this box, but where are we? And if we're kind of thinking about checking trends, we'll check these trends. If not, we hadn't thought about it. Everything's green. We're still heading to something that we don't see, like this guy. And that's a problem. And the answer again is that we need to think more, which is kind of a weird thing to say, but we need to think a lot more about how we're reviewing application development. Go to requirements again, like I said in the beginning. They're changing because we have a spectrum of correctness. What is true may or may not be documented. This can be implemented in a certain way. This can be tested in a certain way. Our all quality picture is wobbly because of these things. Now, we kind of say like, okay, we kind of want to sacrifice this on the holy grail of velocity, which I understand. And we actually want to do the opposite. We want to, because if you actually wanted to do like everything I told you, like you're feeling it, it's going to be a lot of work and it's a lot of pulling brakes here, which we don't want to do. But point is that we need to think differently about things. And I gave you a couple of examples how to do that today. And think differently, think about more about cases or complexity, about risks, about documentation, of course, about code and reviewing and testing. We need to think differently about these things. We need to develop or start to develop new processes, because what we want to do is like not pull brakes, but we want to continue riding the wave. In order to do that, we need to have some way of steering. For that, we need like to shine lights on things that weren't there before. And once we see them, we can at least start to like pulling levers and do something about them. But if we don't, and we continue to do what we did until today, the walls are going to get hit. We want that speed. So remember, what I ask you today is like, when you get back to work, think about it. Well, there's a lot more that we don't see today. Start like mapping these things out. I hope I gave you a couple of examples of monsters in the dark that are waiting to jump on you. And maybe there are more. There are a lot more. Because things are we develop things differently. And this hits all kinds of parts of the development process. And you say, okay, we want to start with automation. Let's start with that. If we're not going to cover everything and we're adding a lot of code, how are we going to do that? Once you start thinking about it, we'll start coming up with the question, with at least some bit of answers. And that's what I wanted to share with you today. So if you have monsters or they are waiting under your bed or behind your CI server and you want to do something about it, 1 hour diagnostic, free. Let me know, fill out the application, and we can do something about. You need to file the application until Monday, 23rd, because this closes this month. And that's basically it. Thank you for coming today. Questions that I didn't see. With many more permutations, do you have tools to help create these in a test plan? And do you have unique methods to track exploratory testing? They're not unique. Everything that I'm thinking like I'm trying new stuff, it always comes back to the old stuff, old from 2 years ago. I do use ways to calculate, at least for permutations, like things in automation, how much am I not seeing? My blindness factor or my coverage blindness factor. So I at least it will give me a way to know how long I have to go. And I'm going to generate the tests, but it's going to be like in small batches where I can review them and tweak them in a way that I will get the things that I want. Nothing unique about that. Exploratory testing, it comes back again to thinking and planning a bit from before we start. Like methodically, what you would do is write some charters and pick the charters based on your priority and explore there. It requires today, it's going to be like the same thing, but we do a lot more planning about this. And it does require a bit more knowing about the system, the stability of the system that we're doing, which APIs we can use to control stuff, which APIs we can use to observe stuff. It doesn't always appear on the screen. What if we have logs, tools that kind of consume the logs, tools and read them and extract what we need. So it's the old combined with the new. For Exploratory, it's a lot more planning ahead because we need to make the most of the time that we almost don't have. We want to try it as much as we can. That's what I have today. Would be very nice to hear about new methods and tools that do that for us. Excellent. Thank you for coming today. Don't forget the monsters. They will not forget about you. And I hope to see you in the next webinars. Bye-bye.